Hello learners, welcome to this program Education Online. I am teacher Akena Patrick Omoy, a teacher of physics, and today we are going to look at the lens formula under the main topic lenses and optical systems. Now for us to look at what the lens formula is, we have to first consider a ray diagram. That is, for one, we are going to start with convex lens. Convex lens. Now in a convex lens, this is how a convex lens appears. Now if this is a convex lens, then we say a line through the optical center is called the principal axis. Then on the principal axis we have the principal foci, that is one principal focus on one side, then another principal focus on the other side, and twice of the principal focus we call it 2f, which is equals to the radius of curvature of the lens. Now as we said, in drawing ray diagrams we are going to consider two rays. That is, one, we shall take a ray that is parallel to the principal axis, and for the case of a convex lens, a ray is parallel to the principal axis and passes through the principal focus after refraction. Then two, a ray which passes through the optical center and deviated. Now if we take a ray parallel to the principal axis, that is one for an object placed, let us take for example an object placed between 2f and f. So this ray will pass through the principal focus after refraction from the lens. After refraction. Then we shall also take another ray which passes through the optical center and deviated, meaning its direction will not change. So if this is a ray, then when we project the first ray, they have to meet at a certain point. They meet at a certain point. So this is where the two rays are meeting. So now in this case, we are going to take the distance from the center of the lens to the object to be letter U. Then we also take the distance between the optical center and the principal focus to be letter F. Letter F. Then also the distance between the optical center and the image, we take it to be V. We take it to be V. So this distance from the optical center to the image is V, meaning it is the image distance. So it is from this point where we are going to get the lens formula. Now the lens formula is given by the relation 1 divided by f, which is equal to 1 divided by u plus 1 divided by v. 1 divided by f is equal to 1 divided by u plus 1 divided by v. So this is the lens formula. That is for an object placed at a certain point with a distance u from the optical center, in which the focal length is at a distance f and an image being formed at a distance v. So now we're going to say where u is the object distance, that is the object distance from the optical center. Then v is the image distance, that is the distance of the image from the optical center, and f is the focal length of the lens. So this is the lens formula that we can use to get either the focal length or the object distance or the image distance, that is for an object placed at any position in front of a convex lens. Then a different formula or a same formula but with different signs can be used, that is when an object is placed in front of a concave lens. Now if we take concave lens, now this is how a concave lens appears. So this is a concave lens. Then a line through the optical center is called the principal axis. So this is the principal axis of a concave lens. Then on the principal axis we have points, and these points are called the principal focus, or we denote it with letter F. Also, we are going to take two rays. One, we are going to take a ray which is parallel to the principal axis, which appears to diverge from a certain point called the principal focus after refraction. That is, if the object is placed between F and 2F. So this ray will be refracted from the lens, and it will appear to be coming from a certain point on the principal axis, which is called the principal focus of the lens. So this is where it appears to be coming from. Then we shall also have a ray through the optical center which goes undeviated, meaning its direction will not change. So these are the two rays that we have. So we shall find that the image is formed in between the focal length and the optical center. But when we look at this image is formed by apparent intersection of rays. So now the formula that we are going to use, since the image is formed by apparent intersection of rays, we take its distance to be negative. And in that case, the focal length will also be negative. So we are going to use the formula 1 out of F, which is equals to 1 out of U minus 1 out of V. This is also a lens formula, that is for image formed by a concave lens. It is taken to be, the image distance is taken to be negative because it is formed by apparent intersection of rays. Now, dear learners, a question can be asked. You'll be either asked to get the focal length, you can be asked to get the image distance or the object distance. Then a question can also be asked. You are to get the position of the image using a ray diagram. So, dear learners, this is how a question can be set. That is how we can use the lens formula, or how we can get the position of the image for an object. So now, taking this example, we have example 1. Example. The example says an object of height an object of height 10 centimeters is placed 20 centimeters from a convex lens, 20 centimeters away from a convex lens. 20 centimeters away from a convex lens of focal length of focal length 30 centimeters. Determine the image distance. Determine the image distance. The image distance. A, using the lens formula. The lens formula. Then B, using ray diagram. So this is how a question can be said. An object of height 10 centimeters is placed 20 centimeters away from a convex lens of focal length 30 centimeters. Determine the image distance. 1 is using the lens formula. Then 2 is using a ray diagram. So dear learners, let's see how we can determine the distance of the image. 1, we are asked to determine it using the lens formula, and 2, we are asked to determine it using the ray diagram. Before we answer this question, you have to keep in mind that the answer that you will get when you use the lens formula should be the same as the one you will get when you use the ray diagrams. So now solution. Now reading through the question, we have to note down what is given. So we shall say given, we shall have the height of the object is given to be 10 centimeters. Then we read further, when we read further, it says it is placed 20 centimeters away from a convex lens. That is the object distance. So we say object distance is equal to 20 centimeters. Then reading further, it says of focal length 30 centimeters. So focal length is equal to 30 centimeters. So these are the quantities that are given in the question. So now the first question is asking us to use the lens formula, that is to get the image distance. So now A, using the lens formula. Using the lens formula. So now the lens formula says, now from 1 out of f, which is equal to 1 out of u plus 1 out of v, where f is the focal length of the lens, u is the image distance, that is the distance, sorry, u is the object distance, that is the distance of the object from the optical center. Then v is the image distance. So now we are going to substitute what is given in the question. We are going to substitute in the formula so that we can get the image distance. So now we are going to have 1 divided by, so in our question focal length is given to be 30 centimeters. So we are going to have 1 divided by 30, which is equal to 1 divided by u, and u is the object distance, which is given in the question to be 20 centimeters, plus 1 divided by v, and v is the image distance that we are looking for. 1 divided by v. So now in this case we are going to collect like terms. We shall find that 1 out of 30 and 2 out of 20 are like terms. So we are going to bring them on one side of the equation. So we are going to have 1 divided by 30. Then when any number crosses the equal sign, its sign changes. Now this is positive. When it crosses the equal sign, it changes to negative. So we're going to have 1 out of 30 minus 1 out of 20. And this is equal to 1 out of v. Now we have 1 divided by 30 minus 1 divided by 20. We are going to get the LCM, that is the lowest common multiple. So now the lowest common multiple, that is the smallest number that can divide both 30 and 20, is 60. 60 is the smallest number that can divide both 30 and 20. So now when you divide 60 by 30, you are going to get 2. Then 2 times 1 is 2. Minus 60 divided by 20, it goes 3. Then 3 times 1 is 3. This is equal to 1 divided by V. Now when you subtract 2 minus 3, 2 is smaller than 3. Therefore, when you subtract a bigger number from a smaller number, you get a negative. So 2 minus 3 gives you negative 1. Divide by 60, which is equal to 1 divided by V. So what we are going to do is to cross multiply. We are going to cross multiply, dear learners, meaning we are going to multiply 1 times 60, then we shall also multiply V times negative 1. We are going to cross multiply. So now when we multiply V times negative 1, is going to give us negative V, which is equal to, then when we multiply 60 times 1, we get 60. So now V is negative, but we have to make it positive. How do we make it positive? We divide both sides by negative 1. So this side by negative 1, then also the other side by negative 1, where the negative and the negative will cancel. That is, negative divided by negative gives you a positive. So we are left with V on the left hand side of the equation. Then 60 divided by negative 1 is negative 60. That is, when you divide any positive number by a negative number, you get a negative number. So 60 divided by negative 1 gives you negative 60. And it is in centimeters. You can summarize and say, therefore, the image distance is 60 centimeters. So this is how we can get the image distance, that is using the length formula. I said the length formula is given by 1 divided by F, which is equal to 1 divided by U plus 1 divided by V, where F is the focal length of the lens, U is the object distance, that is the distance between the object and the optical center, then V is the image distance, that is the distance between the image and the optical center. So this is how we apply the length formula to get the image distance. In the length formula, we are not only using it to get the image distance. At times, the image distance will be given, the object distance will be given, and you'll be asked to get the focal length. We still apply the same formula. Or the focal length can be given, then the image distance can be given, and you'll be asked to get the object distance. You still apply the same formula. Now let's go to the B part of the question. The B part is saying you are still to get the image distance, but using a ray diagram, which means the image distance that we are going to get, that is after constructing a ray diagram, should be the same distance that we have got using the length formula. So now how do we get the image distance, that is using the ray diagram? Meaning we are going to draw rays. And I said when we are drawing rays, we consider 2 out of the 3 rays. We consider only 2 of the 3 rays. So now the B part says we are going to get it using ray diagram. So dear learners, when we are using ray diagram, we are going to draw it to scale. We are going to draw the ray diagram to scale, meaning this measurement of the height, the measurement of the distance of the object, the measurement of the focal length are taken to scale, meaning we measure that same and exact value. So now, when we draw our convex lens, taking this to be the convex lens, this is our convex lens. Then a line through the optical center and the principal focus, we say this is called the principal axis. So this is the principal axis of the lens. The principal axis of the lens. That is a line through the optical center and the principal focus. This is the principal axis of the lens. Now the question says, an object of height 10 centimeters, which means this object is 10 centimeters high, which is placed 20 centimeters away from the convex lens, meaning the distance from the optical center to the object is 20 centimeters. So we are going to measure 20 centimeters. So we place, this is how we place the ruler. Dear learners, we place, then we measure the distance from the optical center, then we measure 20 centimeters. So from the center, 20 centimeters is found at this point. So this is 20 centimeters from the optical center. This is where we place the object. So we take this distance, the distance between the object and the optical center to be 20 centimeters. This is 20 centimeters. Then the question says the object is 10 centimeters high, which means the height of the object should be 10 centimeters. We also measure 10 centimeters using the ruler. So this is 10 centimeters. This is 10 centimeters. That is the height of the object. Then the question again says the focal length of this lens is 30 centimeters. We're also going to measure 30 centimeters from the optical center. So this is the optical center. We measure the distance to be 30 centimeters. So this is 30 centimeters, which is the focal length. That is the distance between the focal point and the principal focus. It is 30 centimeters. Now we are going to consider two rays. That is, we consider a ray parallel to the principal axis. Then we shall also consider a ray, we shall first consider a ray parallel to the principal axis which passes through the principal focus after refraction. Then we consider a ray through the optical center which goes undeviated. Keep in mind that the distance between the optical center and the principal focus are the same on both sides, and we are taking it to be 30 centimeters. So this is point F. So now a ray through the principal, a ray parallel to the principal axis. This is a ray which is parallel to the principal axis. So this ray will be refracted through the principal focus after it has passed through the lens. So this ray passes through the principal focus, that is after refraction from the lens. Then the second ray that we are going to use is a ray through the optical center which goes undeviated, meaning its direction does not change. So this is the ray through the optical center which goes undeviated, meaning its direction does not change. So when we are to look at these two rays that we have drawn, these rays do not intersect. What if we try to project it upward? What will happen, dear learners? When we project this ray upward, we shall find that this ray will appear to come from a certain point. So this ray from the object appears to be coming from a certain point. Then also this ray that has been refracted also appears to be coming from a certain point. So when we look at this ray diagram, we shall find that there's an apparent intersection of rays at this point. So this is a point where the image of the object is formed. The image of the object is formed at this point. This is the image. This is object O, then this is image I. So now to determine the image distance, we are going to measure the distance between the optical center and the position of the image. Now using our ruler, we are measuring the distance. That is the distance between the optical center and the position where the image is formed. So when we measure this accurately, we shall find that this image is 60 centimeters. From my ruler, it is showing 60 centimeters, meaning it is taken to scale. So the image distance, which is V, is 60 centimeters. That is when you measure from the ray diagram. So dear learners, when you are asked a question like this, an object of height 10 centimeters is placed 20 centimeters away from a convex lens of focal length 30 centimeters. Determine the image distance. The A part says using the lens formula. So you have to apply the lens formula to get the image distance. Then the B part is asking you to get it using the ray diagram. And with the ray diagram, we draw it to scale, meaning we measure the actual value which are given. We measure the height of the object as it is given. We measure the focal length as it is given. Then we measure the object distance as it is given. So when the question is asked and you are to use the lens formula, when you draw a ray diagram, the answer will be the same, but you will not be marked right because you have not followed the instruction. Or when you are asked to use a ray diagram and you use a lens formula, the answer will be correct, but you will not be marked because you have failed to follow the instruction. This is how a question can be set. So dear learners, another question can also be set as, you can be given a question as, this is question 2. So you can be given a question which says an object placed 12 centimeters from a converging lens, from a converging lens of focal length 18 centimeters. Find the position of the image. Find the position of the image. So this is how a question can be set. An object placed 20 centimeters from a focal length from a converging lens of focal length 18 centimeters. Find the position of the image. So when you look at this question, it has not been specified. You are not restricted to use the lens formula, and you are not also restricted to use the ray diagram. So it is you to decide which one is appropriate for you. If you want to use the lens formula, it's fine. If you can draw the ray diagram accurately, it's also fine. So it is you to decide what to use. So dear learners, up to this point, I would like to say thank you for attending the lesson. I hope you enjoyed it. I'm teacher Akena Patrick Komoy. Bye bye.